All right, we are going to try question 7 here, and probably get to question 8 too. So we'll do mean value theorem for this function on that interval. Hopefully you just did number 6. Number 7 is a little bit different, but similar ideas. And I'm going to do this one in the way that I think is the most efficient with the calculator. So we want to do mean value theorem for this thing on that interval. So I'm going to pop over to my solution set so you can see that, right? It has the answer here, but you'll see, I want you to see this work right here. So from 1 to 4, that means I need to find f of 4 minus f of 1 over 4 minus 1. Knowing that I'm going to plug that into here, and then I have a calculator, and then I'm definitely going to get decimals with all that sign stuff, I'm going to plug f of x into my y equals screen. So I'm going to go up here. I'll clear out anything that I have, and I'll put it in y1. So x sine x, close. Make sure you're in radian, because if you're in degree mode, it's not going to graph sine correctly for how calculus works. And that's a whole nother discussion. So let's quit. Now, what I want to do is calculate this right here on my main screen. So I'm going to open a parentheses. I'm going to do alpha trace y1, open parentheses at 4, close, minus alpha trace y1 at 1. Remember, I'm taking these two values right here, close, divided by, all right, again, I could do 4 minus 1 in my head. It's 3. But you see what I did there wrong? I forgot my parenthesis. Always double check what you're putting in. So I'm going to go second insert, slide that parenthesis in there, and then get out of there. All right, so boom, now I can hit enter, and I get this number right here. So notice that's what I have right here. And I want to maintain accuracy. When I'm doing these calculus problems, I can't round until the end. I would rather not have to write this whole mess out and then type it into my y equals screen. So what I'm going to do is hit the store button down here, and then I'm going to take alpha and store it as alpha A. Boom. I get this thing right here. So now what I can do is I can go back to my y equals screen, and I can type alpha A into my y equals screen. And as long as I don't change A, it's going to graph this number right here. Because remember, I want to set this right here equal to f prime. So in my y3, I'm going to hit f. I'm going to make f prime. So when I have a calculator, we could do math 8 on this right here and type it into y3. So I'm not going to do this, but I could do math 8 and then type it in here. Problem is, it takes the calculator some time to do this derivative graphing stuff. So it's more efficient, especially with something like this, if I can just quickly do the derivative, which this is an easy product rule and you should be able to do it, and then type that in here instead. And it'll work a lot faster on the calculator. So product rule on this right here, derivative of the first times the second, that's going to be 1 times sine x. And then I'm going to add derivative of the second, which is a cosine x, times the first. That gives me x cosine x. So notice this line right here matches what I have written as f prime right here. So now what I want to do, this one is in y3. This one is in this A is in y2. I'm going to come over here. Actually, I'm going to scroll up. I'm going to turn off y1 by going over that equal sign and hitting enter. And you can see now when I scroll down, it's not highlighted. It's only going to graph these two right here. Now, I could do a zoom 6. I'll go ahead and do it. But I want you to think, whoa, that's a lot of intersections. What can I do to make this problem easier? And your calculator may be taking more time. Remember, you can hit the on button to make it stop graphing. But I got a whole bunch of intersections. What I can do, I only want to worry about the interval from 1 to 4. So I can go to my window, make my x min 1, and make my x max 4, and then hit graph like this, and you can see, oh, I only got to worry about one spot where it intersects. So now I can use the features of my calculator. Second calc, intersect is option 5. We'll scroll down. And then it almost looks like it landed on there. So I'm just going to scroll left a little bit so I can see. All right, so I'm on y2 equals a. For me, it's my red one. And then it pops up to y3. You can see that it highlights it. And then it asks me for a guess, so I'm going to scroll back so I'm nice and close there and hit enter. And then boom, it gives me 2.4629, which I'm going to round up to 2.463. And that's what I got right here. Sweet. Hopefully we're good with that. Let's move on to number 8. Why don't you go ahead and read number 8. You can hit pause. Okay, so we have f of x equals this mess, and we want to find f double prime. So we could double derive that thing using rules that we know from calculus. Hold on a second. Using rules from calculus, we could do that, but what's the derivative of cosecant? Oh, I got to remember the chain rule. So if I have a calculator, to be honest, it might be a little bit faster to let it do the work for me. What I want you to see is I want a double prime here. So I have to go about it a little bit different route. I can't math 8 a math 8 on the main screen, but I can use the y equals screen to do it for me. So watch. Actually, I'll pop here. So the first thing you need to do is recognize that cosecant is 1 over sine. So cosecant of 2x is going to be 1 over sine of 2x. So you need to rewrite this because we don't have a cosecant button on our calculator. I've only got sine and cosine. You may say, well, it's sine to the -1, but that's sine inverse, which we also call arc sine, and it's not the same as cosecant. It's pretty confusing, but it's the way it is. And there's reasons for it that I'm not going to get into here. But so what I want to do is I want to put this function that's right here into my y equals screen. So I'll go back here. I'm going to clear out whatever mess I have. Go up to y1. All right, I'm going to make y1 equal to x raised to the 3rd minus 1 over sine of 2x. Boom. Enter. Now, what did I just do there? I guess I said minus, but didn't type it. Second insert minus. There we go. Okay. All right, so now I need to, that's my y1. What I can do, you can't double do a math 8 on the main screen, but what I can do is do math 8, derivative with respect to x. I can pull up y1 by saying alpha trace, taken 1, and then do it at x equals x. So what this would do is y2, if I were to graph it, it would take some time. I think you've done this before. If I were to graph it, it would give me the graph of the derivative of this thing at any given x value. It would graph it for me. So what I can do is then go to the main screen and do a math 8 derivative with respect to x of alpha trace y2, evaluate it at x equals 1.5 and hit enter. Now, that's a massive negative number, and it's what I would write right here. See, I didn't write it. The one comment I'm going to make on this is that there's a decent chance that this is not totally 100% correct, because when we do derivatives or when we use math 8, the calculator is really estimating a derivative. And when I have like an iterated estimate here, derivative here is the thing, like I'm doing a math 8 here, and then by iterated, I mean I'm doing a math 8 on that out here. There's a chance that it's not going to come out to be correct, but it can give you a really good idea of about what it is. So we're going to roll with that, and hopefully I'll have some more videos for some of the rest of these. All right, peace, y'all.